Hello and welcome to this tutorial, and in this video we are going to talk about functions. So what is a function? A function relates to an input which is in an independent variable to an output which is the dependent variable. We can call it a machine or an expression or a rule that takes an input and gives us an output. Similarly, we can see that we can have x and we get an output of y. Further, which is outside of the scope of this video, is we have domain and range. Therefore, the input represents the domain and output determines the range. So let's see how this works. So we have an input value of x that goes through a function and we get an output of y. In this instance, if we put 1 into the function, which multiplies the value of x by 2, we get 2. If we input the value of 2 that goes through the function, we get the value of 4. And lastly, if we input the value of 3, we get 3 multiplied by 2 and the value of y is equals to 6. There are several ways of how you can represent it. And in this case, we can see that this represents y equals to 2x. And a function can be a linear function, quadratic function, or trigonometric function. And there are several options where these inputs and outputs are expressed and represented. So let's see the common ones. I have given you 3 representations of a function. I have a 4th one on a set theory. But let's map these functions in their respective representation. When the input of x is 1, we have y is equals to 2. And in ordered pair, we have 1, 2, where 1 represents x and 2 represents y. And on a graph, we have 1 and 2. Next, we have the input is 2 and y is 4. Hence, the ordered pair is 2, 4, and on the graph we see the corresponding values of x and the values of y. Lastly, we have 3, which is an input and output of 6. That the ordered pair, the value of x is equals to 3 and the value of y is equals to 6. That corresponds to the value of x is equals to 3 and the value of y is equals to 6. So that is the line represented as y is equals to 2x. If you step further, you'd see that we have set notations where we can represent the ordered pair as a set where we have 1, 2, 2, 4, and 3, 6. That represents our function where the values in blue are inputs of x and the values in red are outputs of y. Let's see what are the limitations of a function. And a function should have only one output of y for every input of x. This is very important and critical when you are defining a function and a relationship. Examples, we have 1 that maps to 2 and 2 that maps to 4. So this is a function because we have only one output of y for every input of x. Next, we have b, where we have one input of 1 that goes to 2 and 2 goes to 2. That's still a function and I'll explain it. Next, we have 1 to 2 and we have 2 to 2. This is also a function. However, once we introduce another relation of 1 goes to 4, then this is not a function. And mapping a number has to be to another unique number. Hence, we cannot have a function that gives 2 different outputs for the same argument. In C, 1 has 2 values, which is 2 and 4. Thus, we call a relation and not a function. Okay? and D, we have 1 that maps to 2, 3 that maps to 6. So what happens to 5? 5 does not have a corresponding value of y, hence it's not a function. If you see B and D, it's actually the opposite of the other, because you can have y values that have no representation of the x, but you cannot have x values without the representations of the y values, which is the output. So you have to be careful on this one. Next, let's visit function notations. So we have y is equals to x plus 1. This is a linear equation, whereby we see the same equation can be represented by f of x is equals to x plus 1, right? So the value of x here is called an argument of the functions, which is written as f of 2 is equals to 2 plus 1, whereby 2 represents the value of x, that is in blue, and y is the same as f of x. Therefore, f of x is written as f in brackets x, which is equals to y. Customarily, functions are denoted by letters such as f, g, and h. And that's the end of my tutorial. Thank you.